tuntraba kan zirtur hi physics unit 8 chapter 1 ani atoms and nuclei atoms akha kan ron zirle don ani voina uluk takin in lo ngai thanga thiam tumin in lo ziranga derivation thui tak kan ti dona in le khabu te khain lo la chuak don nia le ama sabera chuan Bohr's theory of Bohr's atomic model ti hi ni Bohr sakhan atomic model kha lo siam chuaka khami atomic model a siam chua khan he hi a model a chu ni electron hian charged particle nucleus heavy charged particle nucleus chung om kha electron khan akal huala ni a revolve around the nucleus ani apanina chuan electron ho khan an du na orbit a khan in nucleus kha an kal hual top theilawani ta hian conditioner on siam ta ni electrons can revolve around the nucleus only in those orbit in which the angular momentum is an multiple of h by twice pi ani omzia chu hei angular momentum ania hemi angular momentum heti zat an neina orbita chau khan electron khan an revolve theiani tin pathumna chuan energy kha ground state energy te first state energy second te khan energy level che sang kharon omta higher energy level atanga lower energy electron a jam khan energy kha apechua kan in the form of radiation in kha Bohr san atomic model aron siam chua choni Bohr sama khan Rutherford khan atomic model kharon siam chua ka khami Rutherford atomic model kha dik hlelna oma wangin Bohr sen atomic model chi sang kha aron siam chuak vele ta hei hi ani Bohr sa atomic model atang hian hemi atang hianin electron ina nucleus positively charged particle a revolve akal hual na a energy nei te a velocity te a radius engzat nge ani ti te kha voina hianin hydrogen atom mangin kan zirdon ani le Bohr's theory of hydrogen atom hi kan zirtur achuni ta ni hydrogen atom kan lak kher na chan chu hydrogen atom hi simplest atom ani electron pakhat anaya proton pakhat anei ni chuta tang chuan a zero all samawangin hydrogen atom hi kan ron mangdon ta ani hemi hydrogen atom atang hianin engzat nge eng radius in nge electron kha revolve anga eng ang velocity chakin nge akalanga tin energy engzat nge aneyang ti kha tuna kan cho chwa tur chu ni athui deuh leka uluk dawinin lo ngai thadon nya le kan shia again kan soi to angin hydrogen atom a chuan electron pakhata oma nucleus pakhata chuan proton pakhata oma chumi nucleus chu electron hian akal hualani ti hian heta positively charged particle alaya a oma electron khan ti hian akal hualani ti hian electron ti khan positively charged particle nucleus omi electron khan ti khan akal hela ti hian an kalani hemi akal na hianin electrostatic force of attraction kha donani positive charge particle ania alayami hi hei a negatively charged particle ani electrostatic force of attraction coulomb force kan ti kha anin kara hian inhibit na kha donani khami coulomb force kha the electrostatic force of attraction chu engen yang coulomb force mang khan F is equal to 1 by 4 pi epsilon naught more Q1 Q2 by R square ani kha hemi here revolve na a radius kha R kan tiang more this 1 by 4 pi epsilon naught ania charge kha electron le proton ania separated by distance R square hei kan lak chuan 1 by 4 pi epsilon naught E square by R square ani hey equation number 1 kan tiang mom chuan hemi electron hian it is moving it is having a mass m anei ni chuan a revolve khan it will move with some velocity nei in a move don ani so ti chu hemi hi centripetal force omani akwala akalawangin centripetal force omani the centripetal force anin kara khan centripetal force dona kami centripetal force kha mass m neya velocity v in akalani chuwang chuan hemi centripetal force hi mv square by r ani mo hi equation number 2 kan tiang le hemi centripetal force hi engwanga ron nge kan ti chuan hemi le hemi in hi tlat na electrostatic force of attraction awang khani in hi tlat lo seng chon electron hi a thlok chuak dei don ani ma sen in hi tlat awang khanin centripetal force chu hemi force hi ani chu ta chu mi zia tu the centripetal force is provided by the electrostatic force of attraction chu wangin centripetal force le hei hi anin tlukta ani mo the necessary centripetal force hemi centripetal force hi hemi electrostatic force of attraction wang hi ni chu wangin hemi hi a centripetal force chu ani ti na ni chu wangin mv square by r is equal to 1 by 4 pi epsilon naught e square by r square ani nakina heile r le hemi r pakhathin cancel theya tuti chu hwadui nge kan nei le mv square by 1 by 4 pi epsilon naught e square by r hey equation number 3 kan tiang mom equation number 3 thleng kan nei ta ti khan lenichina Bohr's theory of Bohr's atomic model ataka kan mu kha electron can revolve around in those orbit whose angular momentum is an integral multiple of h by twice pi inti kha khami kha kan mangang according to Bohr's quantization mvr is equal to nh by twice pi hey hi equation number 4 kan tia or v is equal to nh by twice pi mr. We'll name this equation number 5. Using equation number, hemi equation hi equation number 3 akan mangang. Using equation 5 in 3. Equation number 3 kan mv square is equal to 1 by 4 pi epsilon naught e square by r ania. Mo instead of v value ki he tami hi ta hian kan substitute don ani chuti chu enge ni tang m v kha nh twice pi mr square is equal to 1 by 4 pi epsilon naught e square by r ani ta ni heta tanga ron chuak le ta chu r value the value of the radius hemi hi kan cho chuan radius value kha lo chuak don ta ni 1 by 4 pi epsilon naught n square h square 4 pi square me square hey hi radius of the electron ina hemi nucleus and revolve na radius aka hemi equation hian min ron pe chuak ta ni hemi equation atanga in mu tur chu 4 pi epsilon naught to constant ani h po Planck constant ani 4 po pi po mass of electron po constant mo electronic charge po constant ani so wangin the only variable term is n hi ni principal quantum number kha r is directly proportional to n square so mi zia chu radius hi khami a orbit na kha san zel chuan n value san zel chuan a radius kha sang zel don ti na ani ta ani le a radius akha kan chut chuak to a tuna chuan atom kha exact velocity in nge a revolve ang ti kha tuna hyang kan chut chuak le don ani le equation kha hei hi kan nei to sa kha ni v is equal to nh by r ani le ta khan Bohr's radius kha r ani hi Bohr's radius kan chut chua to kha ani chu wang chuan instead of this r hey hi kan substitute ve thung don ni direct in ka substitute nga reciprocal ka langal don nia v is equal to nh by twice pi m 1 by 4 pi epsilon naught kimir Bohr's radius value ki ka substitute nia 1 by 4 pi epsilon naught 4 pi square mc square divided by n square h square hey hi Bohr's radius kan cho chua to kha ani ta ni chona in cancel thei kan cancel anga true pi pakhat le heta pakhat hei le hemi pakhat hei le hei hi le chuti chu radius chu enge chi bang ta 4 hey le hey hi la ombok 4 pi epsilon naught v is equal to 1 by 4 pi epsilon naught 2 e square divided by nh. Hey hi the velocity of the electron revolving around the nucleus chu hey hi anitani mo heta pi pakhatala om mo hey hi velocity kha hey hi anitani heta tanga ron lang chiang ta chu v is inversely proportional to n ani zia chu orbit kha asan pole a velocity kha atniam zel don ti na ni chu a revolve na velocity kha atniam hle don ti na ani chu le tuna chuan exact energy in nge electron ho kha an revolve ang ti kha tuna kan chu chwa le tur chu ani ta ni energy of the electron. Let Ek and Ep be the kinetic energy and potential energy respectively. The total energy of the electron revolving around the nucleus to the potential kinetic energy plus the potential energy. Ani electron ka mass m anaya, it is moving with the velocity v and hivangin a kinetic energy to the kinetic energy Ek to half mv square ani le half mv square ani to half mv square ani equation kan lo nei to mv square value hi ta hian ka substitute don ani half 1 by 4 pi epsilon naught e square by r, or we can write it as 1 by 4 pi epsilon naught e square by twice r. Kaka energy of the electron, a kinetic energy of the electron ani tuna chuan the electrostatic potential energy kha kan chui chuak leang the electrostatic potential energy chu electrostatic in zir to ang khan electrostatic potential energy chu hei hi anita ani minus 1 by 4 pi epsilon naught e square by r le tuna chuan total energy kan chu chuak theita a kinetic energy total energy chu kinetic energy plus potential energy ni kha kinetic energy kan nei to a potential energy kan nei to a chu wangin tuna total energy chu kan chu chuak thei to don ani kinetic energy 1 by 4 pi epsilon naught e square by twice r minus potential energy tuna chona total energy chu kinetic energy plus potential energy ani hei hi LCM in langa chuta answer lo chuak tur chu minus 1 by 4 pi epsilon naught e square by r ani hei hi energy of the electron revolving around the nucleus ani heta mai henala top to lo ni hemi r value heta Bohr's radius hi heta han kan substitute le don ani heta r value Bohr's radius kan han substitute khan heti hiana lo omta hemi value kha chuan kan han cho khan hei hi energy of the electron revolving around the nucleus chu hemi equation hi kan nei chu ni ta ani hemi equation atanga ron lang chiang chu energy is inversely proportional to n square ani 1 by 4 pi epsilon naught constant and 2 pi me and by hand constant and h po Planck constant and variable term chu n chia hi ni so wangin e is inversely proportional to n square hemi standard value substituting all the standard value hemi standard value zong kan substitute nu chuan substituting all the standard value E value hi ti hiana ron chuak ta ni minus 13.6 divided by n square electron volt heta hiana ron chuak ta ni zona in nei mai thei ni engatinge energy hi negative ani ti kha zona om thei ani kha zona om reng ani a chan na po energy chu hemi hi negative ani na chan chu electron kha uninbound tlat ani tina ni mo electron hi unbound na nucleus a inbound tlat ani ti en tirnan hei hi a negative value alo chuak ta ani hemi energy hi n is equal to 1 ani hian n is equal to 1 ani hian e is equal to minus 13.6 ani ground state level anti chuni tahan energy of electron hi atlem berani negative a chuan a number tam tam kha tlem ani khamo chuwang chuan hemi negative value ania hemi ground state n is equal to 1 a chuan hemi value hi atlem berani n is equal to 2 a chuan E is equal to minus 13.6 divided by 2 square lo ni tonga hemi E value hi alo niam le tong ma se negative po ni ma niam ma se negative ani awangin hemi ground state energy ai chon hei kha atam jok don ta ni heng ho kha atam jok zel energy kha excited states anti chu ani chuwangin energy te a velocity te a radius te kan chu chuaka khatiang ho zong zong kha uluk dewin lo ziranga a solution a thui dewa tin chin chia tur te alo tam dewa thatakin in lo zir don ania unit 6 chapter 1 ani optics ti ani optics a hian chini kan zir dona 12 a hianin pakhat na chu ray optics ania ray optics chu class 10 ate po in zir to convex lens concave lens te intia image formation te inti kha khang kha ray optics kan ti chu ni voina han ray optics su kan thlur bing big de hlekanga wave optics chu anu le lama te po kan la inzir tir le anga claim te po na har zok ve dewa ray optics ai chuan ray optics a chuan kan rilruar lang masaber chu reflection and refraction of light kan ti khani reflection of light ti hi kan zir kan en le thuak masa anga reflection of light kan ti chuan reflection is a phenomenon of change of path of light from one medium to the same medium without any change in medium om lawa ray of light ina an path a change a in thak nakha khami a phenomenon nakha reflection of light ani reflection om theina tur chu kan thevek nga dar thlang kanin en na dar thalang te heng te hi reflection om na vek ani ti chuan reflection of light chu diagram mang chuan ti hian kan ziak thinani hei hi reflecting surface kan ti khani heta incident ray alo kala incident ray lo kal ni incident ray na reflecting surface atlak adda asudna chi a hian 90 degree a tia kan zia hi hei hi normal anti chu ni hei hi normal hei hi incident ray hemi incident ray hi hemi reflecting surface atlak chi a hian hemi hian apa takha athla kanga ti hian aron chule don ani mo hei hi reflected ray chu hei hi ani ta ni incident ray le normal in kara angle om hi angle of incidence reflected ray le normal in kara angle om hi angle of reflection ani reflection hian lo reflection of light hian lo chi ni pahni ani chumi lo chu in sevek to ang karinga the incident ray the normal and the reflected ray all lie in the same plane ti kha alo pakhat na chu ani law number 1 the incident ray alo pakhat na chu the incident ray normal and the reflected ray incident ray normal le reflected ray hi they all lie in the same plane ani apahni na le hi apoi mota ni the angle of incidence a second law chuan the angle of incidence is equal to angle I is equal to angle R hemi law pani hi law of reflection a kan nei te chu ani adota kan zirle tur chu refraction of light ani hei po hi in hriat vek to nu nia class 10 a refraction of light hi chu change in the path of light when it goes from one medium to another medium ama kha chuan in reflection a ka chuan medium ngaya air ani chuan air a bokoron chuak leng tuna chuan light kha medium pakhat atengin medium danga akal tlang le don ani kha refraction of light anti chuni hei hi refracting surface ani example glass slab te pon yang refracting surface ani incident light ti hian aron kala incident light tlak na taka line kan zia kha normal kan ti kha normal hei hi air ti chu glass ai chuat alo rare dewani a medium kha alo a density te kha lo claim dewani rarer medium atanga denser medium alu khan light kha it will bend towards the normal hei hi angle of incidence ania hei angle of refraction ani hei hi refraction a light kal dan chu ni denser medium atanga rarer medium atanga an chua chuan the light will bend away from the normal ani entirnan hei hi glass slab ania glass slab atang han ray hi ron chuak ta ang se ti hian hei hi normal ania hei incident ray ni glass atangin dense atangin rare aron chua chuan hemi refracted light hi it will bend away from the normal hei hi angle of hei incidence ania angle hi angle of refraction ani hei hi light kaldan ani hemi hi it will bend towards le away from the normal ani theina hi nakina karon cho puidon chewani le refraction po hian lo chini pani anei ani pakhat chu amami ang bokhan alo pakhat na chuan the incident ray normal and the refracted ray all lie in the same plane kha alo pakhat na ani alo pani na hi apoi moa the sine of the angle of incidence to the sine of the angle of refraction is constant in kan zir thin ani hemi constant hi refractive index ania hemi refractive index hi it is denoted by a Greek letter mu n te po nan denote nga text budanga mu te po denote amang ma se refractive index ani ti kha in sin sia tlat don ya hemi lo hi apoi mo mani hemi lo hi aming pakhata chuan snail's law anti bok thin hei hi snail's law anti bok khani nakina hemi hi light hi engatinge towards the normal ania away from the normal ani ti nakha hemi lo mang te hian kan ron chu chui chua kanga tin hemi lo hi man na tam ema in lo sin sia don nia sine of the angle of incidence to the sine of the angle of refraction is constant. That constant is called refractive index ania mu in ka denota ka so ito ang kan n ponan ron denotang hei hi refractive index anti chuni le refractive index hi a formula a chuan speed of light in air divided by speed of light in a medium tepon an chui chuak ve thin bokani le absolute refractive index ni china sine of the angle of incidence to the sine of the angle of refraction a mu kha a definition a chuan speed of light medium ani annotation a chuan c is speed of light in air so ina khania speed of light in a medium chu v ani hei hi unit less quantity ani asan chu helam hi speed ania helam po speed ani a unit ka in cancel dona chu bangin refractive index hi unit less ani ti kha in sin sia bok don ne oh hei hian unit anei lo refractive index hian hei refractive index ani hemi mang hian anything a light hi bend towards the normal ani a bends away from the normal ani ti kha kan ron chui chuak don ani refraction don om chana chu light shim hi medium pakhata tanga medium pakhata luhen a speed hi in thakani rarer medium a chuan akal chaka denser medium a chuan light hi akal muang ani the velocity decreases when light enters to a denser medium ani kha khami mang khan hemi bent away from the normal let towards the normal kha kan ron soifia don ani kha cause of refraction anti chuni cause of refraction bent away from the normal let towards the normal karon a chua dan khain lo chin sia don ya tuna kan chok don ani light hi rarer medium a chuan a velocity kha v1 ni se tin denser medium a velocity kha v2 ni se mo ti chuan light hi rarer medium a chuan a kal chak zo ka wangin v1 is greater than v2 ani let's snail's law atang khan from snail's law. Snail's law khan sine I by sine R is equal to refractive index ani. Refractive index khan enge formula kan ti kha speed of light in air divided by speed of light in a medium ani. heta hi chuan speed of light in rarer medium to speed of light in denser medium ani v1 by v2 ani. Since v1 is greater than v2, I is greater than r. Hemi zia chu speed of light v1 hi v2 ay atam chuan angle of incidence hi angle of refraction ay atam zok don tina ni tani. Angle of refraction hi atklem zok chuan angle of incidence ay claim chuan it bends towards the normal. This is why light bends towards the normal. Adot lea chuan when light travels from denser medium to rarer medium ani. Le v1 hi speed of light in denser medium kan tianga, v2 hi speed of light in rarer medium ani. At dense kha chuan speed hi claim don ani. A rare at chak zok chu wangin v1 is smaller than v2 ani. Hei from snail's law kan soile chuan sin I by sin r is equal to v1 by v2. Since v1 is smaller than v2, sin I is smaller than sin r. So that is I is smaller than r. More angle of incidence ka angle of refraction ay na claim zok don ani. So wangin angle of incidence heti hian alo amta angle of incidence hi. Hey hi angle of refraction ay na claim zok. So ti chu angle of refraction chu he te o mangay tati nani. Hey hi rarer denser medium atingin rarer medium aron chwa kani. Hey hi a zia chu ni. Mo this is why light bends away from the normal. Hey hi denser atanga rarer chwa le rarer atanga denser chwa light bends away le towards the normal. So if ya naka anita ani adod le kan zir tur chu total internal reflection ani. Total internal reflection chu it is a phenomenon of reflection when light travels from denser medium to rarer medium with an angle greater than the critical angle. Khatianga light ka denser medium atanga rarer medium aron chua critical angle ay tama light ka incident khan light ka refraction ni to lawin reflection alo ni to thinani. Light entirnan hei hi medium ani denser medium ani hei hi tiyan denser medium oma light ka dense atangin rare athuak don ani. Hei hi dense hei denser medium hei rarer medium. Mo ani nataka chon heta hian refraction omani refraction ni turani tihan light aron kalta heta normal ania dense atangin rarer athua wangit it will bend away from the normal ani. Hei I ania hei r he tihan incident rate ka tihan kalta ni. There will come a point pakatulaw amang chuta chuan hemi angle of incidence englo hi refraction hi he takal to lawin he tia huna law thengang mo helai angle refracted ray hi he tia akala hemi angle tak angle of incidence atak hi critical angle anti chuni hemi critical angle aya tamalai thi incident to chuan critical angle ay tamalai thi incident to chuan refracting surface po khanima se refraction to lawin light kha a reflect to don ani heta hian heti zong hian hemi hi total internal reflection kan ti chuni hei hi chinchia ro critical angle ani. Critical angle a chuan angle of refraction hi 90 degree ni. Hemi critical angle ay tamalai thi a incident khan refracting surface po ni ro se tui po ni ro se glass po ni ro se mo eng po ni ro se refraction ni ma se refraction to lawin light ka avain reflection to nga reflecting surface angena ron to don ani kha total internal reflection kan ti chuni. Total internal reflection tur hian du huna theilawani light hi dense atangin rare athuak nge tur ni rare atanga dense lu chuan total internal reflection theilaw dense atangin rare athuak nge tur ani tin a angle of incidence kha critical angle in atam nge turani kha total internal reflection theina tura condition pani kan nei chu ani ta ani le hi total internal reflection thlen theina tura condition pani chu kan nei chu ni ta ni light hi denser to rarer medium akal turani kan sei to angkhan rarer to denser medium akal chuan total internal reflection theilo ma tin angle of incidence hi critical angle hemi critical angle ayatam ani nge turani chumi ni huna chuan total internal reflection theini hemi point pani hi uluk takin chin cheula in thai phei chuan memorize ngal ula thang question a chuang ngun te mai nia le tuna chuan relation between critical angle le refractive index critical angle le refractive index hi engtin gi an lo in relate ve sim ti kha kan chu chuak don ani critical angle a chuan I kha critical angle C kan tiang mon chuan critical angle ni chin diagram kan en khan critical angle ani khan angle of refraction hi 90 degree ani kan ti kha in lam huanga ti chuan in Snell's law mangin kan chok don ani hei po hi Snell's law kha poi mu ka ti kha Snell's law mang hian thil hi kan chok chuak de ureng don ani le Snell's law mang chuan mu b refractive index of medium B to refractive index of medium A sin C sin I turania hai critical angle ani wangin C ka da hai sin R turania sin R hi 90 degree ni wangin 90 degree ka dang mo to di chu sin 90 chu engzat nge sin 90 chu 1 ani so wangin mu A into 1 to di chu critical angle chu mu BA is equal to 1 by sin C. Hey, relationship between refractive index and critical angle. Anti chu ni tani. Total internal reflection hi aman na chi sang amani. Ama sabera chuan diamond te lo en na chan kha brilliance of diamond te. Le application of total internal reflection to brilliance of diamond ania mirage inti chu kan shaveka desert te kan ka ankala tui omlo na puya tui muanga ning sian na ang chi te khana in zirvek to optical fibers hi kan zira apoi mole ta chu poi mole chu ni optical fibers hi in shavek to nga he endoscopy ti te point om to nga ko chungan enna khamia shrui an manakha optical fibers ani khata khan mora khan light to oma khami light khan pum thla te khan lata light pakhat ma abo bang am lawin aron thon chua ka heta computer screen aten en chin kha khami kha optical fibers anti chuni optical fibers a hian alai taka hian optical fiber hian alai hian core anei tani hemi core hi a very fine glass high quality glass asiamani mo ti chuan chumi zo chuan cladding ti omle hemi glass lo tuam phui tu chumi zo chuan buffer coating ama chumi chu plastic thachi in an cover le thine ni hemi chunga khan light aron lu khan heti hian total internal reflection oma heta light lo lu thi ti hian hemi wire chunga hemi chunga high quality glass atang khan total internal reflection khati khana om ta zela ti chuan heta changa signal light lo lu te ray lo lu te reng kha without loss of intensity light khan a en na bow lo lin a quality bow lo khan light zong kha they are totally internally reflected ti chuan khatianga ni wang khan thil kha chiang dewin ani na ango khan kan mu thei thi na ni chu kan soi tong khan nat na mu chua nan te endoscopy ti nan te mo light signal mun lat takatanga transmit nante mo telecommunication ti nante po khan optical fibers hi an mang thin ani lekhati zong kha tuntuma kan zir thei chunia uluk takin lo zir le ula poimo tak te kha kan zir le ni danga kanin mule don nia